We're good?
You look good.
I mean, every day. But is the camera working? That's good. Thank you, Craig. All right. Everybody good? Whatever just happened on that quiz is going to be okay. Whatever colleges you've been accepted to, you're still going to be able to go to them. Whatever ones you haven't been accepted to, it's not going to change. It's all going to be okay. It's all going to be okay. HCC is a fabulous campus. They're all over Houston. Lots of openings. Maybe not funny because we're all stressed about this. Okay. So yesterday and the day before we talked about the indefinite integral. Today we're going to come back to the definite integral. That means that all your answers now are going to be numbers. I'm so excited about the fact that we're finally going to return to the land of numbers here. So the goal is to be able to evaluate definite integrals without the graphing calculator. You are upgrading your skills today, Michelle and Flor and Jesus and everybody else in between. No more calculators needed when you evaluate a definite integral because we have skills. I will teach you the skills. I am well trained in the Jedi arts. So you guys may remember something called the FTC, the Fundamental Theorem of Calculus. How many of y'all remember the Fundamental Theorem of Calculus? And if you don't remember that, you know where to look for the Fundamental Theorem of Calculus. So many people know where to look for the Fundamental Theorem of Calculus. Rubio, you're closer than everybody else. What's the Fundamental Theorem of Calculus?
F of B.
F of B
is equal to F of A.
Is equal to F of A.
Plus the definite integral.
Plus the definite integral.
Of F prime.
Of F prime. From A to B. From A to B. You might want to check out your glasses. It's much smaller font. Fundamental Theorem of Calculus, we're okay with this, right? The Fundamental Theorem of Calculus is a connection between the derivative and the original function. And I hope everybody's okay with that. Both of these are talking about the original function. This guy over here is the derivative. Well, in a lot of calculus textbooks, they don't use little f and f prime. They say this. They say big F of B is equal to big F of A. What do I mean by big F? The antiderivative. That the antiderivative at B is equal to the antiderivative at A plus the integral from A to B of little f. So now this guy here is your original function. This is the guy that we're interested in. And big F is the antiderivative. It's the exact same thing because we know that if I take the derivative of the antiderivative, you get to little f. I think we're mostly okay with this? Well, if this is true, then doesn't it also have to be true that the integral from A to B of f of x dx, the definite integral of a function, how would I evaluate the function? It's going to be big F evaluated at B minus big F evaluated at A.
Is that an E or A?
Is it a what?
Is that an E or an A?
That's an A. It was just a really pretty fancy A. If I'm asked to find an evaluate a definite integral, you find the antiderivative evaluated at B. You find the antiderivative evaluated at A, and you subtract those two. It's just the fundamental theorem of calculus with some items moved around. Now, a notation that I'm a big fan of, we're going to write this as big F of x, and then that vertical bar, we haven't seen it in a while, but the vertical bar means, it means at, it means evaluate, it means plug in. So I'm going to write it this way, x equals A and x equals B. We're used to using the vertical bar to just say at one little point. This now says from a point to a point, but it still means evaluate. So when it comes to evaluating a definite integral, you're going to find the antiderivative, you're going to plug in the top limit, you're going to plug in the bottom limit, you're going to subtract the two, done. We're okay? All right, let's do it. Let's do it. Okay, two model problems that we're going to do. We're going to do it by hand. It's going to be okay. No one is going to get hurt. And then you guys are going to get lots of practice time. So, here we go. First problem. Can I get... Eval, can you read that problem for me, please?
A definite integral of 3x squared minus 2x plus 1 in respect to x equals -1 to x equals 2.
From x equals -1 to x equals 2. Okay? So this guy here, the integrand, well, that's your original function. How am I going to go and find the definite integral? I need the antiderivative. I need to know what function has this as its derivative. And I would expect everybody knows that answer. What has 3x squared minus 2x plus 1 as its derivative? Take like 5 seconds. 4, 3, 2. Everybody, what is it? The antiderivative of 3x squared minus 2x plus 1 is?
X cubed.
X cubed.
Plus,
Careful.
X squared.
Minus x squared
Plus 1x.
plus 1x
Plus Charlie.
plus Charlie, because we don't want to forget Charlie. This is your antiderivative, and you've just demonstrated a strong knowledge of calculus, so I get to award a point because you know how to find the antiderivative. Now, yesterday and the day before, we would stop here because this was the answer. We wanted a function. This time, it's a definite integral. It's an area. I want a number. The fundamental theorem of calculus says we need to evaluate this at -1, at x equals 2. So we're going to plug in. Now, I want to get you guys in the habit of this. You're going to plug in the top number. You're going to subtract from that the bottom number. Those parentheses are going to be really important to group the things together. So if I plug in 2 cubed minus 2 squared plus 2 plus Charlie. I plug in the -1. Well, -1 cubed, need parentheses there, minus -1 squared plus -1 plus Charlie. If you really want to get excited, you can stop. If this is the free response, you can stop here and you just earn the next point. I want us to keep going though, and I want to simplify as much as possible to get you ready for the multiple choice part. On all homework assignments, you will have to simplify as much as possible. But that's not too bad, right? We got 2 cubed 8 minus 4 plus 2 plus c, -1 cubed -1, -1 squared is 1, minus 1 plus c, nothing too crazy here. 8 minus 4 is 4, plus 2 is 6, plus c minus -1 minus 1 minus 1, that's -3 plus c. Right, I'm just evaluating, I'm just doing my number stuff here. Final answer. 6 plus c minus -3 plus c
9 plus C.
is going to be 9, because 6 minus -3 means 6 plus 3, and the c's cancel out and we get 9. Now, we've not done this before. At least we've not done it by hand. I want you to double check. Let's make sure I'm not lying to you. So plug this in on the calculator. Make sure you're actually getting 9, and I didn't just make up magic stuff.
It's not funny.
All right, how many of you guys are getting 9 on the calculator? Okay, good news, your calculator works. 9, check. Tonight, on the homework, and anytime you're working on the homework, you are 100% invited to check the work that you just did on your graphing calculator. However, if you don't show me the work, you get no credit. On the test, you're expected to be able to do this by hand. We're doing the check on the calculator just to make sure I'm not lying. All the friends are good? I think for many of you, you're good to go. The training wheels have been taken off the bicycle. Go. If you want to stay with me on this next one, stay with me on this next one. You guys are about to switch into some practice time. All right, new one. Sylvia, can I get you to read this one?
The definite integral from, wait, do I read the function first and then from one?
I prefer reading the function first.
Okay.
So it's the definite integral of
1 over x.
1 over the cubed root of x.
1 over the cube root of x plus the cube root of x from 1 to 8 with respect to x.
Okay. Normally I would say like it's the definite integral of this function with respect to x from 1 to 8. Next year in college, some of you are going to have professors that say it's the definite integral from 1 to 8 of the function. That's okay, as long as all the things come out. So the key is I have to find the antiderivative. I have to find the indefinite integral. This one is much harder than before because this isn't something you just recognize. But anybody get Anybody get a good idea? How are you going to start? Anybody at all have a good idea? Anybody at all who's able to read an inch down? Rebecca, what was that?
You have to rewrite the integrand.
You want to rewrite the integrand? Rebecca, how am I going to rewrite the integrand here?
X to the negative 1/3 plus.
What? That's so good. You're going to rewrite this as x to the negative 1/3 plus x to the 1/3. Is everybody okay with doing that? I am not going to give you all the hints in the world. Okay, if I rewrite as x to the negative 1/3 plus x to the 1/3, thank you for reading the hint at the bottom. Why am I going to do that? Because now, good news, you've got power rule. You've got power rule. Now this guy over here is power rule and n is equal to 1/3. This guy over here is the power rule and n is equal to positive 1/3. Get up.
For the first one, why couldn't you use the ln?
Because this isn't 1 over x. It would have to be just the integral of 1 over x to say it's the natural log of the absolute value of x. If it's not 1 over x, not going to work. Okay? All right. Power rule. Power rule says add 1 to the power, divide by the new power. All right, we should be getting better at this. If I add 1 to the power, negative 1/3 plus 1 is 2/3. And then what?
Times negative.
Uh-oh. Add 1 to the power and then
Bring the power down.
that's multiplication. The power rule, let me give you a little side note over here. Power rule says add 1 to the power and then we divide by the new power. Right? Because the derivative would say bring the power down and multiply. So if I add 1 to the power, I get x to the 2/3. 1 divided by 2/3, you guys all know what that is.
3 over 2.
3 over 2. Okay, plus, let's do it again. Antiderivative of x to the 1/3. Power rule says add 1 to the power. So that's 4/3. So x to the 4/3, divide by that new power,
3 over 4.
you get 3 over 4. Plus Charlie from 1 to 8. Good news, you at least have 1 point for finding the antiderivative. Jackie, what's up?
How can you add plus c to the 3 over 2x to the power 2 over 3?
So the plus, that's a really good question. So you're saying, why don't I add the plus c over here and add the plus c over here? I only need that plus c to show up 1 time for the whole problem. All right, where do we do next? Plug in, we're going to plug in the 1, we're going to plug in the 8, and which one gets plugged in first?
8.
That 8. So everything when you plug in 8 minus everything when you plug in 1, and as Destiny said, parentheses, because I want you to group things well here. So we plug in 8. 3/2, 8 to the 2/3, plus 3/4, 8 to the 4/3 plus c. Plug in the 1, 3/2. 1 to the 2/3, 3/4, 1 to the 4/3, plus c. If you make it there, good news. You just earned a point, because everything's a number. I won't let you leave that on the answer on homework or multiple choice. I expect that you know how to simplify. A little scary. A little scary. Jose, help us out here.
I was gonna ask if you could use calculator to do this one.
I want you to be able to do this without the calculator. Is it the 8 to the 2/3 that's freaking everybody out right now?
Yeah.
8 to the 2/3. Let's do a little side work here. 8 to the 2/3 is the same as the cube root of 8 squared. Cube root of 8 is 2. 2 squared? 4. Now, some people are going to say, no, 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 no. I know it as the cube root of 8 squared. Well, what's 8 squared? 8 times 8 is 64. Cube root of 64? What times what times what is 64? 4, so guess what? Either way, it doesn't matter to me. Okay. So 3/2 times 4 plus, oh God, 8 to the 4/3. Take a minute to think about that. 8 to the 4/3. I need the cube root of 8. What times what times what is 8? 2. Raise it to the 4th power. 2 times 2 times 2 times 2 is 16. So 3/4 times 16 plus c minus 3/2 1 to the 2/3. Cube root of 1. What times what times what is 1? 1. 1 squared? 1. Plus 3/4. 1 to the 4/3. Cube root of 1. Still 1. 1 to the 4th is 1. Oh yeah, why did I even bother doing that? 1 to any power is 1. For reals. Okay, I do expect you to be able to simplify further. 3/2 times 4. 3/2 times 4 is really 12 over 2, which is 6. 3/4 of 16. Well, 1/4 of 16 is 4. So 3/4 is 12. Minus 3/2 times 1. 3/4 times 1 plus c. The c's cancel out. 12 plus 6 is 18. 3/2 plus 3/4, get a common denominator. 6/4 plus 3/4 is 9/4. Final answer, if you simplify and get a common denominator, 63 over 4. Check it on the calculator, make sure I didn't lie. Sometimes I go so fast I start lying. You get 15.75 in the calculator? 15.75? 63 divided by 4 is 15.75. Everybody okay? Okay, quick show of hands. How many of y'all are feeling pretty good about going from here to here? Like that's the calculus part, right? That's the calculus part, yay! Everything, this next part, plug in the 8, plug in the 1, that's not too bad. I can pick up that point. I think this is where people start to get freaked out, and this has nothing to do with calculus at all. This is just like all the previous skills. Anybody notice anything about the C's? They canceled out both times. They're going to cancel out all the time. What that means is you don't have to write the plus C if you're doing a definite integral, because your answer is going to be a number, a specific number. So if you don't write the plus C here, that's okay.
So why we don't have to remember here?
You don't have to write the plus C if it's a definite integral.
So the one without the indefinite integral.
An indefinite integral, if you don't write the plus C, dead. Everybody good? All right, let's get the cups out. I want you guys to get some practice time. And I'm going to put 4 minutes on the clock. The person who scored the highest on the little quiz that we just did, you're in control of the cups. We got 4 minutes. Be a proud papa. You have to simplify as much as you can.
So which one? I thought it was the only x power, x to power. Right. Oh, that was one of the power things we said this year. I don't know if it's best here a minute to find it. What is that?
5 minutes, next one is the sine of 2 theta. American.
K is a constant, 2 is a constant. Oh, come back to pop. Thank you very much.
Oh my god, this is like I just really don't know English for it is a personal class.
A little bit of a check-in here. All is going well. You're in a good place. If you found the antiderivative, get negative cosine theta plus 1/2 sine 2 theta. How many of you guys had that as your antiderivative? Congratulations, you just picked up your first point. And walking around, I'm seeing just about everybody. Negative cosine of pi over 2 plus 1/2 the sine of 2 times pi over 2 minus negative cosine of 0 plus 1/2 sine of 2 times 0. Good news. 2 points. And if this was the free response part of the test, my advice to you, leave it alone. Don't simplify. Even Roberto on the BC exam, I don't want him simplifying on the free response, but I'm not going to show this on the multiple choice. You have to be able to simplify, so keep going.
Right.
Oh no, K is a
Well, you have to do that first.
It's a K?
You need the y value, and then you're going to need to figure out when is that general solution.
Sure you know the part.
No, it's don't make sense.
Where is that? Maybe there, and you're going to solve it for Let's keep going. Keep going.
Or 3?
I take back what I said. Let's do it.
Alrighty, Rudy. Okay, next one. Integral of e to the 2x is 1/2 e to the 2x. Integral of e to the negative 2x is negative a half e to the negative 2x. I'm going to evaluate from negative 1 to 1. Saw this on a whole lot of papers. First point earned. Notation stuff. Notice I'm not writing the integral anymore, because this is the antiderivative. Don't write that. No. I'm not writing the d. Oh, heck, I didn't even write the dx over here. Mr. Trier, north side, is going to put a note in our OneNote about that. There should have been a dx over there. Okay? From here, you're going to plug in parentheses minus parentheses 1/2 e squared minus a half e to the negative 2, 1/2 e to the negative 2 minus 1/2 e squared. That's what you get when you plug in. Second point. Okay, how many guys got both the antiderivatives and both of the plugins? A couple of folks, not nearly as many as I was hoping for. Okay, if you went and you simplified this guy further, well, you need to know that cosine of pi over 2 is 0. 2 times pi over 2 is pi. Sine of pi is 0. Minus cosine of 0 is 1, so that's negative 1. The sine of 0 is 0. And so this whole guy reduces down to positive 1. We're going to have to work on the trig stuff. Now, anybody see any simplifying we can do here? The 1/2, we got a lot of 1/2s. I got a 1/2 e squared. Anything I can combine this with? Jackie, what do you see? Not taking derivatives. I'm just looking to clean this up a little bit. Gonzalo, what do you see?
I was gonna distribute that negative and then I think that cancels everything out.
Alright, so you're saying you want to take this negative and distribute?
Yeah.
That's okay. 1/2 e squared minus a half e to the negative 2 minus a half e to the negative 2 plus a half e squared. What else could we do here? What else can we do, Paul? What do you see? Where do you see like terms? 1/2 e squared with another 1/2 e squared is really e squared, right? 2/2 e squared or e squared. So that's this guy here and that guy here. Minus 1/2 e to the negative 2 minus 1/2 e to the negative 2 is just going to be minus e to the negative 2. All right, we get about 6 minutes left. For these last two, if you're feeling good about integration and you just need a push, fly. Fly, monkeys, fly. Go as far and as fast as you can. Let's not worry about the simplifying on these last two. And for those of you that want to work through these two with me, that's what we're going to do. Who are the folks that are working through this with me? Okay, everybody else, you're going solo? Fly, monkeys, fly. All right. All right, so number 5. The definite integral from 0 to 16 of square root of x times x minus 1 with respect to x from 0 to 16. As soon as I look at this problem, I'm already starting to worry. Why? Anybody see anything that is automatically making me worry? Jalissa, what do you see? In fact, not only can we distribute, we're going to have to distribute. If I see multiplication in the integrand, it's bad news. It's just bad news. So you're going to have to do a little bit of algebra trickery. So square root of x times x minus the square root of x, I'm going to integrate that. That's still tricky. Square root of x times x, that's still multiplication. That's still not something that I've memorized yet. So I need to do something else. How about rewrite it? Square root of x is the same as x to the half times x minus x to the half. let's see. Anything else that we could do that's going to move us forward? Karina, what do you say?
When it's like multiplying, don't you add the exponents? So it's gonna be
When you're multiplying and the bases are the same, we add the exponents together. X to the 1/2 times x, right? You've got that like sneaky hidden exponent there of a 1. So x to the 1/2 times x to the 1 is really x to the 3/2 minus x to the 1/2. Are we at a point where we can integrate this?
yes.
We should be. It should be power rule and power rule. X to the 3/2. The power rule says add 1 to that power. 3/2 plus 1 is 5/2. I'm going to start going faster with the fractions. Add 1 to the power. Divide by the new power. So 1 divided by 5/2. 2/5 minus x to the 1/2. I've got to find the antiderivative of the indefinite integral. Add 1 to the power. X to the 3/2, divide by that new power. 2/3. That's good. Now we evaluate from 0 to 16. And you've earned your first point already. Next move. Plug in parentheses minus parentheses. 2/5 times 16 to the 5/2 minus 2/3 times 16 to the 3/2. 2/5, 0 to the 5/2, 2/5, 0 to the 3/2, and we do not have enough time to worry about simplifying at all. If this is the free response part of the test, full points here. On homework tonight, you have to simplify. You need to get ready for the multiple choice, that's how you're going to get ready. Questions on this one? Really? How would I, this one? How would I simplify here? 16 to the 5/2 means find the square root of 16, which is 4, and raise 4 to the 5th power. 4 times 4 times 4 times 4 times 4 is 1,024. Nobody else in the room knows that, and everyone's blown away. And we still have 2 minutes, so I'm not sure anyone's packing up yet. Okay, number 6. Number 6. Definite integral from 1 to 9 of t squared plus the square root of t divided by t squared. This is another one that's going to be scary. Because we don't like multiplication or division in the integral. So you need to do some algebra trickery. Who's got some ideas? What could you do? We've done this a couple of times in the last couple of days. T squared plus the square root of t divided by t squared. 3 people, only 3 people, looks like 4. Birthday girl, what do you got?
I was going to break it down first into their own fractions. So t squared plus square root t over t squared.
Is that legal?
Yeah.
Absolutely, that's legal. And why is it better, Destiny?
Since they're separate, it's easier for us to break it down.
Okay, so t squared divided by t squared, anybody know what that is? 1. Plus, now square root of t divided by t squared, I don't know that you're going to know that right away, but there's something you could do here.
Rewrite it.
That's right, square root of t is t to the 1/2 divided by t squared. And you guys know and know pretty well that when you multiply, the bases are the same. We add the exponents. What do you do when you divide? Subtract. So your integral is integral from 1 to 9 of 1 plus t to the 1/2 minus 2 negative 3/2 dt, and you finish it from there. Okay. The homework that you guys are going to do this weekend, it's more like 1 through 5 that we did. You're just going to get practice. I'm picking this up on Monday for sure for a grade. Do not blow it. Get this done. You need practice. See you later. Wait till you see Monday. So remember, this is the good old days. Here's the